All right, we're dealing with formula rearrangement. That is where there's less numbers, I suppose, and we're dealing with more variables in a sentence or equation. We're trying to solve it, but we won't get a final numerical answer. We're just trying to rearrange it. So this one asks for y to be the subject. So you solve it similar to the way you would solve a normal algebraic equation. You would go about isolating this y, because at the end of this question we want y equals all the rest of the stuff. So our first step here will probably be to minus the 5 from both sides, as if we were trying to solve it. That will remove the 5 from this side, so we get x minus 5 is equal to negative cy. How will I get rid? I can divide by a negative c here, both sides. And that will leave me with just the y. It's not great to leave a negative dividing by a negative. It's not great to leave it like that, but it's okay for now. Let's do a second example. Of course, there's some famous formulas that may come up. I'll look at a few famous formulas. Y is mx plus c. If I want to rearrange this one so x is the subject. Let's do this one. So x is the subject. I would minus the c from both sides. Y minus c is equal to mx. Next step then, this is a multiplication of m, so I divide by m, both sides. So remember, you just do the same thing to both sides, even if it's letters instead of numbers. So y minus c over m is our answer here. Any other famous formulas we can think of? Don't say the quadratic one, I don't want to do that one. What's the most famous formula in physics? Einstein? Oh, that's a boring one, but we can do that one. Charlie comes up with a squared equals b squared plus c squared, Pythagoras. But it's a good one for square roots, maybe, if we want to make c the subject. You would automatically subtract b squared from both sides. So you get a squared minus b squared is equal to c squared, which we use a lot when we do Pythagoras' theorem if it's the shorter side. But if you want c on its own then, if you want a general formula, it's the square root of a squared minus b squared. We should put a plus or minus if we square root. I think actually the IGCSE do not punish you if you forget the plus minus. But I definitely prefer to see it. Any other famous formulas we can rearrange before I pick a... Oh, E equals mc squared. Which letter? We'll go C again. It's the hardest, I think. First step here, Ozzy?
Define C, divide by m.
Yeah, divide by m. So we get E over m, this cancels, is equal to c squared. And then the same process, isn't it? The square root. Some of these formulas, you can remove the negative because you're not allowed to get a negative answer, especially one in real life. What is C again? E equals mc squared.
Energy equals mass times...
I'm not. Is it the speed of light? C squared? Is it the constant speed of light? I can't remember what c squared is. Killian.
Are you going to punish us for the plus or minus in our test?
No, I won't. No. I'll take the GCSE. I did last year, but I won't this year. I'll be nicer this year. Okay, there's another example. All right, I'm going to do a trickier one. It's always trickier if you have to factorize, which is why we did factorizing before this. I'm going to pick one where you have to factorize. I had one written down here. Y is equal to 3x plus 2, x minus 1, and of course x is the subject. How do I know I have to factorize this one straight away? More than 1x, yeah. Yeah, so it tells me I have to factorize at some stage. First step here, Kalim. Panic? Yeah, good.
Okay, multiply that.
Yes. So if I multiply, so I have a division here. I don't want this to be a division. I want this to go away, if you will. I can multiply both sides by x minus 1. And that will get, because this divides perfectly into this once I've got rid of that division. You can think of this as cross multiplication if you want. So I get 3x plus 2 here still. And this one's multiplied by y. So I get xy minus y. So I have now 2 y's as well. Next step. So I want, what do I want at the end of this? I want what? X equals. Yeah, so what I want to do is, I'm not switching them because that would be getting an inverse. I would maybe just bring everything the same as you were solving. Bring x's to one side and anything else to the other side. So if I was solving this equation and it was all numbers, I would try and combine these two somehow. And I'll do the same here. I'm going to subtract 3x from both sides. I just want all the x's on this side. So I get xy minus 3x. These cannot be combined yet. Minus y is equal to, that goes away, 2. Now I'm doing this kind of slowly. You could probably do this a lot quicker than me. I'm going to add this y then on this side because it's not an x, so it can pop over here. So I'm at this stage. You probably could have done that straight from here to here maybe. Just this, it goes here and this, you're swapping sides really. Next step then is the factorizing bit, isn't it? If I have two x's and I want to get it down to 1x, I can factorize it out. So I factor it out, and I have y minus 3 remaining here. That's just a common factor. And I have 2 plus y still. And my final step, remember factoring is, yeah, it's you divide. Because in fact, this is two things that multiply to give this. So to do the opposite to multiplying, I divide by minus 3, y minus 3. That will be 1, and I have my answer, 2 plus y minus 3. Okay, so you'll notice that at the start of that question there was 2 x's, so that made it more difficult to make it a subject. You had to factorize it down to 1x. Okay, so that's formula rearrangement. We'll now do simultaneous equations.
What's going to be on the test?
Everything. So your test is on algebra. It's going to be all of algebra. So this is the stuff we did last year. We're just going over it again. And we'll be adding a little bit to the end of it. And then I can ask you any algebra question that can come up.
And we're going to have like a revision.
This is revision from last year.
No, like we're going to have like
You'll have a revision, you'll have a practice test, and you'll have an actual test. Yeah. Okay, simultaneous equations. Okay, what are simultaneous equations? Okay, you give me an example, but maybe geometrically or what? Yeah, it will have x and y in both of them. Geometrically, what does it look like? As in a picture? If you two equations on top of each other? Oh no. That's you're talking algebraically again. What it looks like if I write it down. I want to, if I drew a diagram, what would it look like?
lines that never touch.
Lines that never touch. Maybe the exact opposite to that.
Lines that cross.
Lines that cross. Yeah. And when you solve, so this you hopefully remember from coordinate geometry is a linear equation. It looks like a line. It has a gradient of 2 and an x or y-intercept, of 3. If you have two of those things, that's two lines, and when you solve them, you're finding the point at which they cross over. The x and the y values match. So you'll see visually, you'll draw a line like this. That'll be line 1. That'll be y is equal to 2x minus 1 or something. And then line 2 will go like that. That'll be y is equal to probably something like minus 3x plus 3, something like that, where those two lines meet. And that'll be that. That's the only place where they'll ever share a point. And that's why there's only one solution there. You get one solution. You'll get an x value and a y value, and that's a point that can fit in here. That's the only place they cross. Okay, so that's what we're trying to find when we solve simultaneous equations. We're going to use two methods to do that. Let's look at this one, 1 minus 2y. We're going to solve this one a different way. Okay, can any remember the names of the two methods or how the methods would work?
You want to try and get two of the same, so you make that you times 1 by 2 to get 2y.
Yes.
Cancel that. Or you want to get plus 2y. You want to cancel.
Okay, so that's what you're describing, Charlie, is the elimination method. We try and eliminate the y's by making them the same but opposite signs. This method, it has been rearranged. Yes, it's called the substitution method. I'm setting up here that you sub one into the other and you solve for one variable. I'll do this one first because it's probably the one you haven't done most recently. This is set up so x already equals something. So if x equals this, then this x must also equal that at the same point. So I can substitute this value for x into there because I have x equals. So my first line of this one is taking that second equation and replacing it. Because how do I know that's true? Because the x's in both lines must be the same when they cross over for this reason. That x value is the same in both lines. So if this one has this x value, it must be the same in this one when it crosses over. So you see, I've just replaced this x with this from the equation 1. Remember, these are two different equations. Like this, two different linear lines. They're crossing somewhere, we find it. And then, at this point, this is now one equation with one unknown. So it can just be solved from this point. I can just apply this 2 in, 2 minus 4y. Okay, these are just rewritten. And then I can solve it like a normal linear equation. So I have 2, and I think this gives me just negative y is equal to 4. What's y going to be here? Minus 2. Yeah, you can work this out. You can add the y over here and subtract this, but the y will be minus 2. So hopefully you can get that far. Is that my job done? No. Yeah. So you've only found half the solution. I know this is not the solution to this, but you've only found half this point. So I need to find the other half. How do I do that? Another substitution, yeah. So I know y is minus 2. Which one can I use? Can I use the first or the second? I can use either. It'll work for both. It should be the exact same point on both. So I'll use the first because it looks easier. So you pick which one looks easier. Y is equal to 1 minus, or x is equal to 1 minus 2. Not y anymore. I know what y is. Y is negative 2. So what's x? Yes, 1 minus 2 times minus 2 is 4. Add the 1 is 5. So my solution is x equal to 5, y equal to, you can put this as a point if you want. And that is the point that these two lines cross over. The elimination method is probably the one you're more familiar with. This is easy if it's already pre-set up like this. Like this is already x equals. This one is not x equals. You would end up with fractions if you tried to do this because you'd have to divide by 3 or divide by 5. So substitution, if I would use it if it avoids the fractions. Elimination might be a little bit easier if you got coefficients here in front of the x. Okay, so the theory behind elimination is we eliminate either the x's and the y's at the first stage, and we pick which one we'd like to eliminate based on which one looks easier to do that. Agreement on the y's look like an easier move here. Because if I multiply this second line by 2, that'll be minus 2. I can multiply by minus 2, and that becomes plus 2y. If I have a situation where I have if I have minus 2y plus 2y underneath each other and I'm adding them, that just cancels or eliminates. So that's what I want to get.
You can also make it minus 2y, right?
You can make a minus 2y and then subtract.
Yeah.
I usually do make it minus and then add, but it's the same theory. Okay, so I draw a line underneath. I call one number 1 and one number 2. Number 1, I'm just going to rewrite. 5x minus 2y is equal to 17. And line 2, I'm going to multiply by negative 2. Does multiplying by something change what the line would look like? No, it won't, no. If I multiply this line by 2, 2y is equal to 4x minus 2. That would still simplify, and it would still go through minus 1 and would still have the same slope. It would just be written 4 over 2 instead of 2 over 1. 4 over 2 is the same as 2 over 1. So it doesn't change it. It's algebraic manipulation to help us. So if I multiply by minus 2, I get minus 6x. Make sure you multiply everything. Plus 2y minus 18. And then I just work out each of these. 5x take away 6x is a negative x. 2y plus y and 2y is the thing that eliminates, it's gone. And then I have 17 take away 18, which is minus 1. If negative x is equal to negative 1, positive x must be just 1. Once again, I've only found half the point, so I'll do the second half of the question. I'll pick either one of these. Maybe I'll pick line 2. It looks a little bit easier. So instead of 3x, I have 3 times 1. What's my answer for y? Minus 6. Yes, it would have to be minus 6. You can multiply this out to be 3. Over here, it'll be 6. And then negative y is equal to positive 6. So positive y is equal to negative 6. If you can do that quicker, that's great. And that's your answer. Okay, time for you guys to do some. There's some classwork up on ManageBack. Get going.